Thank you very much. We'll now proceed directly to the presentation by the Canadian Nuclear Safety Commission, which is based on PMD 14-P1.2b. Dr. Thompson, please proceed.
Merci, Madame la Présidente. Bonjour et bonjour au commissaire. Mon nom est Patsy Thompson. I'm the Director General of the Directorate of Environmental and Radiation Protection and Assessment with the Canadian Nuclear Safety Commission. With me today are Dr. Richard Goulet, a biogeochemist with the CNSC, who led the CNSC staff's review of OPG's radioactive waste inventory, Dr. Sun Nguyen, who reviewed the post-closure safety assessment, Mr. Mike Jones, a chemical engineer working in the Environmental Compliance and Laboratory Services Division, Mr. Ram Kameswaran, a technical specialist working in the Systems Engineering Division of the CNSC. Mr. Kameswaran is a chartered chemist with over 30 years of experience in the nuclear industry. In addition to other members of the CNSC staff's technical review team, we have the support of two explosive experts to respond to questions from the panel in this topic area. Mr. Richard Bose, the head of the Explosives Certification and Hazards Analysis at Natural Resources Canada, and Mr. Patrick Brousseau, the head of the Munitions Energetics in the Weapons Systems section of the Defense Research and Development Canada. CNSC staff provided a review of the impact of OPG's updated radioactive waste inventory on both the pre- and post-closure safety assessments, both in our sufficiency reviews for the information requests, as well as in PMD 14P1.2. Today's presentation summarizes CNSC staff's review as presented in that PMD and provides some further information in response to submissions from interveners. I will now pass the presentation to Dr. Goulet.
Thank you, Dr. Thompson. Okay, thank you. Good morning, Madam Chair, members of the Joint Panel Review Panel. My name is Dr. Richard Goulet, and as Dr. Thompson noted, I'm a biogeochemist with the CNSC in the Environmental Risk Assessment Division. I led the CNSC staff review of OPG's radioactive waste inventory submissions. For the benefit of the audience today, CNSC staff will first provide background as to why the radioactive waste inventory is the subject of discussions today. Then, CNSC staff will address information request EIS 13514 by first discussing the impact of including radionuclide activity from pressure tubes and garter springs on the results of the post-closure safety assessment. The presentation will include a discussion on how radionuclide activities from pressure tubes and garter springs affect the radiological safety of members of the public and nuclear energy workers during normal operation of the proposed DGR. CNSC staff will also discuss how updates to the radioactive waste inventory affected the assessment of consequences of potential accidents, malfunctions, malevolent acts. Finally, CNSC staff will discuss OPG's proposed inventory verification plan and whether the proposed plan meets international standards on waste characterization, is likely to reduce uncertainties in the activities of radionuclide in different waste streams, and thirdly, ultimately, reduce the uncertainty in the pre-closure and post-closure safety assessment. The radioactive waste inventory and its importance to the pre- and post-closure safety assessment was discussed during the hearings last fall. CNSC staff expected reasonable knowledge of the variability in the radionuclide activity in different waste streams from different nuclear generating stations over time. Good quality data provide a reasonable confidence in the radionuclide transport model and ultimately the predicted dose to members of the public, workers, and the environment. In early 2014, Dr. Greening wrote to the panel noting that the radioactive waste inventory did not include radionuclide measurements made on pressure tubes and garter springs. The GRP requested OPG through information request EIS 13514 to indicate how the pre- and post-closure safety assessment could be affected by the new data that was provided by Dr. Greening. CNSC staff reviewed the responses provided by OPG for EIS 13514. In our sufficiency reviews, CNSC staff provided the following. First, the basis of the review. Second, the criteria used to review the information request. Third, the original assessment of the pre- and post-closure safety assessment. Fourth, how the updated radioactive waste inventory modified CNSC staff conclusions. And finally, whether or not the updated radioactive waste inventory affects previous recommendations on the environmental assessment and license application. To begin, I will first address the implication of the changes in the radioactive waste inventory on the post-closure safety assessment. CNSC staff reviewed the calculated doses from the normal evolution and disruptive scenarios based on CNSC regulatory document G320, IAEA's or International Atomic Energy Agency's specific safety requirements SSR 5, International Commission on Radiological Protection or ICRP's recommendations in publication 122 entitled Radiological Protection and Geological Disposal of Long-Lived Solid Radioactive Waste, and the EIS guidelines to determine if the calculated doses resulted in an acceptable risk and met the dose limit of 1 millisievert per year, as well as the requirement to keep doses as low as reasonably achievable. To determine if the DGR project would not impact the health and safety of workers, public, and the environment, CNSC staff accepted OPG's proposed criteria for public radiological exposure at the design stage. For the normal evolution of the DGR system, the criteria for public radiological exposure is 0.3 millisievert per year to the most exposed individuals. So it's 1/3 of the public dose limit of 1 millisievert. For disruptive scenarios, calculated impacts are judged against a dose criterion of 1 millisievert per year. The probability of a disruptive scenario is considered by adopting a human health risk criterion of 1 in 100,000 years. These criteria are more stringent than recommendation of the RCRP publication 122. In the original assessment, all maximum calculated doses for the normal evolution scenario and its many variant conservative scenarios were at least 100,000 times less than 0.3 millisievert per year. CNSC staff concluded that the 4 disruptive scenarios proposed by OPG were sufficient to assess the risk and were considered bounding worst-case scenarios. The calculated dose from these scenarios were around the public dose limit of 1 millisievert per year. The consequences of the updated radioactive waste inventory on the safety case are therefore minor. Please note that there was an error on page 44 of PMD 14-P1.2. The doses predicted in the disruptive scenarios are not 100,000 times below the public dose limit of 1 millisievert, but rather around this dose limit. Sorry. The difference between the maximum calculated doses in the 2011 post-closure safety assessment and the updated calculation for the normal evolution scenario in variant conservative cases as well as for the disruptive scenarios, range from a decrease in the effective dose of 0.6% to an increase of about 7.5%. The consequences of the updated radioactive waste inventory on the safety case are therefore minor. These differences are considered small because the total DGR inventory only increased by 10% for 4 radionuclides in comparison to the 2011 post-closure safety assessment. 4 of these radionuclides, which are nickel 59, has a half-life of 76,000 years. Nickel 63 has a half-life of 18 years. Cesium 137 a half-life of 30 years, and curium 224 a half-life of 18 years. These half-lives are shorter than the time period when the maximum effective dose is predicted to occur, which is more than a million years. As a result, other radionuclides like iodine-129 often are the contaminant of interest. Iodine-129 is the contaminant of interest in other safety cases around the world. The updated calculation of maximum predicted doses based on the revision to the radionuclide inventory in pressure tubes and garter springs does not change CNSC staff's conclusion regarding the long-term safety of the DGR project. CNSC staff continue to conclude that the assessment of the long-term safety of the DGR is sufficiently conservative to support 1. An environmental assessment decision, and 2nd, to authorize a site preparation and construction license. I will now address the implication of the changes in the radioactive waste inventory to radiological safety to workers during normal operation, or in other words, during pre-closure operations of the proposed DGR. CNSC staff based their review on the additional information provided by OPG in response to EIS 13514. And we based our assessment based on Section 5 of the Class 1 Nuclear Facility Regulations, as well as other provisions from the Radiation Protection Regulations. CNSC staff confirmed the radiological dose assessment methodology and calculations using MicroShield version 8.02. MicroShield is a comprehensive photon shielding and dose assessment program that is widely used for designing shields, estimating source strength from radiation measurements, minimizing exposure to people, and teaching shielding principles. CNSC dose limit for nuclear energy workers is 50 millisievert per year and 100 millisievert over 5 years. The criterion used to determine the safety of workers during normal operation is OPG's occupational dose target of 10 millisievert per year for workers. However, licensees are expected to keep doses as low as reasonably achievable. And consequently, if the project goes ahead, OPG would be required to implement an ALARA program as part of their radiation protection program. CNSC staff had previously reviewed the input parameters for the radiological dose assessment for all scenarios used by OPG to assess doses to workers, including scenario 2, which involved the handling of retube waste packages. CNSC staff had concluded that the results of and methods used by OPG were acceptable. OPG had adequately assessed the potential radiation exposure scenarios and anticipated radiation doses associated with the proposed DGR project. Radiation exposure and radiation doses to workers were predicted to be less than CNSC regulatory limits, dose limits, sorry. Further, implementation of physical design and administrative controls as required by an operating license, if the DGR is approved, will ensure that radiation exposures and radiation doses are kept ALARA, or in other words, as low as reasonably achievable. Finally, all waste packages must meet the acceptance criteria before being placed in a DGR. Upon examining OPG's revised dose assessment for the retube waste package scenario, CNSC staff calculated similar results as OPG for the updated radioactive waste inventory. It is recognized that there is a fourfold increase in external dose rates to DGR workers associated with the revised pressure tubes inventories. However, the retube waste packages must meet the DGR acceptance criteria before the workers would handle the waste at the DGR facility. For instance, OPG would need additional shielding or decay time so that all packages meet the waste acceptance criteria. Consequently, no scenarios would, in practice, lead to doses above the 10 millisievert per year criterion. Other ALARA measures will be incorporated to further reduce worker doses prior to placement of waste into the DGR. For instance, dose rates would be further reduced by shielded forklifts and the use of overpacks. OPG has committed to address these ALARA measures in the final ALARA assessment for the DGR that would be required for an operating license application to operate the DGR. The additional information provided by OPG in response to EIS 13514 does not change CNSC staff conclusion in PMD 13-P1.3 that radiation and radioactivity resulting from the DGR project are unlikely to have significant adverse effects on the health of humans, including workers, taking into account the implementation of mitigation measures. It is important to note that a waste package would not be allowed into the DGR if it does not meet waste acceptance criteria. This will be ensured by actual measurements in the field by both OPG employees, and these measurements will be confirmed during CNSC staff inspections. The updated assessment, including mitigation measures such as waste acceptance criteria and ALARA requirements, provides evidence of the safety of the DGR during operations and to support both an environmental assessment decision and to authorize a site preparation and construction license. This concludes the first part of the presentation. I will now pass the presentation over to Mr. Mike Jones to continue with the assessment of the updated radioactive waste inventory in relations to accidents, malfunctions, and malevolent acts.
Thank you, Dr. Glay. For the record, my name is Mike Jones. I am an Environmental Program Officer in the Environmental Compliance and Laboratory Services Division. I am the lead in the review of accidents, malfunctions, and malevolent acts for many environmental assessments of the CNSC, including for this project. The objective of the CNSC staff's review of OPG's EAS with respect to accidents, malfunctions, and malevolent acts was to identify and describe possible accidents or malfunctions associated with the proposed DGR project and the potential adverse environmental effects of these events. Sufficient quantitative information needed to be provided on all radioactive and hazardous substances that could be released to the environment in significant quantities. The review also needed to address potential environmental effects that could result from intentional malevolent acts. CNSC staff's review included a validation of OPG's assessment methodology and calculations. OPG chose to apply the limits from the radiation protection regulations in their assessment: an annual dose limit of 1 millisieverts for members of the public and an annual dose limit of 50 millisieverts from workers. CNSC staff also considered these limits in our assessment. However, it should be noted that these dose limits are for normal operating conditions and would not apply in accident scenarios. During an accident, the occupational dose limits may be exceeded as per Section 15 of the Radiation Protection Regulations during the control of an emergency and the consequent immediate and urgent remedial work. The radiological accidents and malfunctions assessment submitted in the EAS was conducted on credible scenarios during the site preparation, construction, operations, and decommissioning phases of the proposed DGR project. It adequately demonstrated that acceptable dose criteria for workers, members of the public, and non-human biota will not be exceeded. All credible accident scenarios were well below the annual dose limit to the public of 1 millisievert per year. Although the effects were generally small, OPG proposed mitigating measures and contingency plans. CNSC staff concluded that OPG's assessment was adequate. The assessment conducted on potential malevolent acts of sabotage and attack during the site preparation and construction, operations, and decommissioning phases of the proposed DGR project determined that, in general, radiological and non-radiological consequences of credible malevolent acts are expected to be similar to those of the malfunctions and accidents considered in the assessment. OPG concluded that impacted non-human biota would be limited to the vicinity of the DGR project, and there would be minimal impact to members of the public. However, extreme malevolent acts, such as the use of explosives, can cause worker fatalities in the vicinity of the incident. OPG concluded that malevolent acts are bounded by the malfunctions and accidents, resulting in relatively low radiological consequences to workers. CNSC concurred with OPG's assessment. OPG reassessed the original accidents, malfunctions, and malevolent acts scenarios using the revised radiological waste inventory. CNSC staff reviewed the reassessment and concluded that the revised accidents and malfunctions scenarios would not have significant radiological consequences on members of the public and workers. For all revised accidents and malfunctions scenarios and most malevolent act scenarios, the dose consequences to workers and the public were well below the regulatory limits. The one exception was malevolent act scenario D, involving a person using an explosive or incendiary device affecting wastes on the surface awaiting transfer to the DGR. This scenario was reassessed to focus on retube waste package. In the scenario, the assessment using the original retube waste inventory resulted in a dose to the public of 2 millisieverts. The revised inventory for retube waste was also reassessed and resulted in a dose to the public of 3 millisieverts. This would exceed the annual dose limit to the public of 1 millisievert, but would not result in measurable health effects. The scenario is very unlikely due to the difficulty in targeting a specific package, the robustness of the containers, the quantity of explosives necessary, and the tight security in place at the Bruce Power site. I will now pass the presentation over to Mr. Ram Kamaswaran to further discuss.
Thank you, Mr. Jones. For the record, my name is Ram Kamaswaran. I am a technical specialist with the Systems Engineering Division at the CNSC. When PMD 14-P1.10 was received from Dr. Greening, the DGR assessment team at the CNSC requested my review of concerns regarding the malevolent act scenario of a person using an explosive of incendiary device affecting wastes on the surface awaiting transfer into the DGR. The main comment from Dr. Greening was that the OPG had not estimated the source term correctly based on the pyrophoric property of zirconium metal in the pressure tubes. Dr. Greening also stated that the OPG has treated the detonation of zirconium as an inert metal and not as a reactive metal, and the assumptions and values used by OPG to calculate the source term is incorrect, and the resulting dose to the public should be significantly higher. Before I continue, I would like to provide some definitions and characteristics of zirconium metal. Pyrophoricity refers to a property of spontaneously heating and igniting in air below 55 degrees Celsius. Pyrophoric behavior is common in many metals under specific conditions. Zirconium metal is pyrophoric only when it is in the form of very small particles less than 54 microns in diameter. OPG pressure tube wastes are larger pieces with little powders of fines. The material of this size is not readily ignitable, and this was also shown by the OPG in their video that shows zirconium pressure tube waste pieces are not readily ignitable even under extreme temperatures. Dr. Greening also questioned OPG's source term methodology as it related to the assigned airborne release fractions ARF and the respirable fraction the RF. The main comment was that OPG had not estimated the source term correctly based upon the pyrophoric property of zirconium metal in the pressure tubes. OPG used a 5-factor formula from the United States Department of Energy Handbook 3010, which provides the airborne release fractions and respirable fractions for non-nuclear facilities, and this was developed for the source term calculation. OPG obtained ARF and RF values from the published U.S. Nuclear Regulatory Commission Handbook, NUREG CR 6410, which is the Handbook for Nuclear Fuel Cycle Facility Accident Analysis Handbook. CNSE staff find the use of the DOE Handbook 3010 and the US NRC Handbook 6410 to be acceptable source of information. CNSE staff concluded that the selected ARF and RF values were appropriate for the scenario, the stress material combination for the scenario. Based on the malevolent act scenario D, the explosive force from detonation was identified as an explosion, and this is different from what Dr. Greening has claimed as an implosion. The appropriate airborne release fraction and the respirable fraction values were selected following the standard methodology used by the USNRC. The suggestion by Dr. Greening that ARF and RF values should both be 1 and the resulting dose to the public much higher does not align with the scenario, the stress and material combination, in line with the methodology that is suggested by the USNRC document. Therefore, CNSE staff conclude that OPG has appropriately and conservatively assessed the source term and the resulting public dose for malevolent act. To conclude this section on accidents, malfunctions, and malevolent act, CNSE staff conclude that applying the revised inventory to accident scenarios would not have significant radiological consequences on the members of the public or workers. The pre-closure safety assessment is sufficiently conservative to support the environmental assessment decision and authorize a site preparation and construction license. I will now pass the presentation back to Dr. Gole to present CNSE staff assessment on the inventory verification plan. Thank you.
Thank you, Mr. Kamaswaran. For the record, as I noted earlier, my name is Dr. Ishar Goulet. I will now present the final section of the presentation, an overview of CNSE staff assessment of OPG's commitment for an inventory verification plan, or as I will call it, the IVP. CNSE staff previously concluded that the level of conservatism in the contaminant transport model and depth of the proposed DGR project was sufficient to support the post-closure safety assessment of the DGR project. More specifically, conservatism in the contaminant transport model led to doses 100,000 times less than the 0.3 millisievert per year dose criterion, and disruptive scenarios led to doses around a millisievert per year. Despite the large safety margins in the assessment, CNSC staff still expected OPG to reduce the uncertainty in their radioactive waste inventory during the construction phase and demonstrate that the maximum predicted doses in the pre- and post-closure assessment remained essentially unchanged. These expectations were described in recommendation number 2 in PMD 13P1.3 and discussed during the hearings in the fall of 2013. CNSC staff expect the radioactive waste characterization program to comply with international standards and guidance. These guidance are the 2009 International Atomic Energy Agency document entitled Determination and Use of Scaling Factors for Waste Characterization in Nuclear Power Plant, as well as the 2007 ISO 21238 standard entitled Scaling Factor Method to Determine the Radioactivity of Low and Intermediate Level Radioactive Waste Packages generated at nuclear power plants. CNSC staff also contracted an independent third party to review the original radioactive waste inventory. The contractor, D.W. James Consulting, has over 30 years of experience in characterizing nuclear waste and actually participated in writing the ISO 21238 standard. This independent expert review was used by CNSC staff to formulate recommendation number 2 presented in PMD 13P1.3. Recommendation number 2 of PMD 13P1.3 was used to review the IVP submitted in response to information request EIS 13514. In particular, the IVP should account for the variability in the packages and assure representativeness, including providing particular details on sample coverage and frequency. The IVP should also implement interlaboratory verification of radionuclide measurements. The IVP should also use alternative analysis methods to update better detection limit on certain radionuclides, for instance, iodine-129. It should also commit to a schedule for implementation. And finally, the IVP should help to demonstrate as a requirement for the operating license that the post-closure safety predictions remain essentially unchanged. OPG provided the following information in response to information request EIS 13514. Overall, OPG committed to collect at least 3 samples per waste type for all waste types to screen levels of radionuclides, hazardous substances like metals, and organic material important in gas generation predictions. Then, for important waste types and key radionuclides, a minimum of 10 data per nuclide per waste type will be sampled to quantify the 95% upper confidence value, which is the activity value that is above 95% of measured activities in the sample collected. These data points will also include extended time frames. These data points will also include at least 2 from each nuclear generating station where appropriate and cover an extended time frame in order to provide basic information on variability between stations and over time. Hence, the IVP now proposed by OPG accounts for the variability in the packages, will assure adequate representativeness, It also provides particular details on sample coverage and frequency. Finally, it will improve detection capability to quantify key radionuclides that are difficult to measure, such as iodine-129. If the project proceeds, CNSC staff would verify implementation of the IVP and confirm its effectiveness. OPG IVP also meets other aspects of recommendation number 2 of PMD 13P1.3 as follows. First, accredited laboratories will measure radionuclide activities, and interlaboratory comparisons will be done approximately every 3 years. This meets the expectation that OPG implement interlaboratory verification of radionuclide measurements. Second, an independent third party will review the waste characterization program. This is also a CNSC expectation. And finally, verification activities are planned up to 2021, leading to a license to operate, which meets the expectation that OPG commits to a schedule for implementation. I will now discuss how uncertainties would be handled. International guidance in IAEA SSG 223 recommends to identify uncertainties in the safety case and to confirm that these uncertainties do not influence safety. The main objective of recommendation number 2 was for OPG to obtain more measurements on the activity of radionuclides in the radioactive waste that are important to the safety case. More direct measurements of difficult-to-measure radionuclides will lead to more accurate data on the radioactivity in the waste and less uncertainty about the source term used in the safety assessment. As more information on the radioactivity of difficult-to-measure nuclides becomes available, the safety case will be updated accordingly. OPG provided information on uncertainty in the waste inventory characterization in the EIS and provided further information in response to information request EIS 0106 and EIS 0120, which were proposed by CNSC staff. After reviewing all of the information, CNSC staff concluded that OPG had adequately identified the uncertainties. Then, OPG needed to convince CNSC staff that this uncertainty would not affect the safety case. OPG's approach to deal with this uncertainty was to properly bound the pre-closure and post-closure safety assessment. OPG bounded their assessment by overestimating the radionuclide activity, assuming radionuclides are more soluble than they are in reality, and by assuming that they will not bind to the rock matrix along their diffusion pathway. Considering that even with these conservative assumptions, most doses were 100 times lower than the 0.3 millisievert per annum threshold, and considering all the other conservative assumptions used in the contaminant transport model, CNSC staff concluded that the assessment was properly bounded and that the uncertainties with the radioactive inventory did not impact the long-term safety case. Despite the assessment being properly bounded, CNSC staff expect OPG to follow best international practices on radioactive waste characterization and proceed with further characterization during construction. This approach is similar to the operation permit for the repository of radioactive operational waste in Sweden, which requires waste activity description to be approved by the regulator before emplacement in the repository. To conclude the section on the IVP, OPG's proposed IVP meets the commitment to reduce the uncertainty in the waste inventory by committing to deriving the 95% upper confidence interval value for key radionuclides in waste important to the safety case, and characterizing hazardous substances, metal, and carbon availability in waste which are important in predicting gas pressure inside a DGR in the long term. OPG has provided a schedule for implementation of the IVP and committed to completing it in time for the application for a license to operate if the DGR project proceeds. CNSC staff concludes that the proposed IVP addresses all but one expectation of recommendation number 2 of PMD 13 P1.3. The last expectation of recommendation number 2 is to demonstrate as a requirement for the operating license that the predicted doses in the post-closure safety assessment remain essentially unchanged. CNSC staff would verify this last expectation by confirming implementation of the IVP when reviewing annual updates of the radioactive waste inventory. Should OPG seek an operating license, CNSC staff would thoroughly review the updated pre- and post-closure safety assessments. This ends CNSC staff assessment of the impact of the updated inventory on the pre- and post-closure safety assessment. I will now pass the presentation back to Dr. Thompson to present CNSC staff overall conclusions.
Thank you. I will now present staff's overall conclusions. In light of our review, CNSC staff concludes that the proposed radioactive waste inventory verification plan addresses all but one expectation that CNSC staff laid out in recommendation 2 of PMD 13P1.3 regarding uncertainty in the original radioactive waste inventory. The updated radioactive waste inventory that includes measurements of activity in pressure tubes and garter springs does not significantly change, 1, the assessment of long-term doses to people and biota, secondly, the dose predictions to workers as long as mitigation measures are in place, and finally, dose predictions to workers in the event of an accident. OPG proposed radioactive waste inventory verification plan is acceptable to CNSC staff as it meets regulatory requirements. In addition, the pre- and post-closure safety assessments are sufficiently conservative to support an environmental assessment decision and to authorize a site preparation and construction license. I will conclude this presentation by reiterating that no package would be allowed into the DGR without external dose measurements and adequate characterization of radioactive waste inventory to confirm compliance with OPG's waste acceptance criteria. This ends the staff's presentation, and we're available to answer questions.
Thank you, Dr. Thompson and your colleagues.